that, couldn't you, with a ruler?
Well, that would be quite difficult to do because you'd have to have a perfectly straight line to measure it against.
Yeah, you got to have a straight line.
It would be very easy to measure out 3
Well, that's where the distance of the local horizontal comes in.
Ruler that's straight over 200 meters. Do you have that? No, you don't.
Yeah, I can mark it with a pencil. Don't worry about the method, Rumpus. I'll do that.
You do that.
So what you are listening to is a video that was uploaded by Cleary. I'm assuming it originally came from Brandon, so shout out to both of you. I'll put a link to the video I got this from, which is on Cleary's channel, so you can go and check it out. And what they're discussing is the physical geometric sphere edge horizon that is required by the globe Earth model. And what you're going to hear is quite a lot of discussion about this representation on screen. You can probably see with a line pointing to the straight line that's required to do geometry, it states tangent to Earth's surface. And this is required by a globe Earth model that has a requirement for an R value, which is clearly labelled in this particular depiction. So I'm going to play out a little bit more because it actually gets to a section where you see all of Rumpus's obfuscation tactics in terms of the depictorial evidence that he presents. So we'll play it through and then I'll give you my comments and make some suggestions.
Measure that though, couldn't you?
Well, you'd have difficulty. You'd have to do it. You'd have to do it optically.
No, I can mark a pencil mark and I can mark another pencil mark and I could tell if there was 3.1 millimetres difference between those two pencil marks.
How wide are your pencil marks?
What straight line are you measuring the 3 millimetres against?
What's the local horizontal with the water level?
Don't worry about the method, Rumpus.
How wide are your pencil marks?
Realise the problem.
What's the distance of the horizontal?
How wide his pencil is?
You would have to get.
You would have to
this
3
pink
millimeters,
line,
man. That's not a lot of...
This pink line, you would have to create this pink line, and then, this is exaggerated here, you would have to have that in place to then measure it down to the ground and then say, oh, this is 3 millimetres. But you need this mechanical thing here, unless you're going to do it optically.
Nah, you don't.
Optically doesn't work.
What do you do with your eyes closed so you don't do it optically? I mean, damn, you got to open your eyes if you're going to do anything.
What was it?
You don't understand.
Coplanar points.
Jeremy, did you have a question? Jeremy?
Right. Hopefully we've now dealt with the...
Rumpus. Jeremy, did you have a question?
Okay.
Yeah, how long is that local horizontal? Is it?
Okay, so now we're at the diagram he had prior to this one, which he did lots of drawing on and justified how he could have a curve meeting a tangent. Now, the black line, as he was phrasing it, is the tangent, and it's the only line that remains consistent in all of his presentations. So the question that needed to be asked, and it was used in aggression by Rumpus, is where'd you get the tangent? Because that straight line, this black line on screen, and consistently in the other presentation that was on prior, are straight. And you can't acquire one from a sphere that's got bent lines to the horizon, i.e. refracted. And that is precisely what the rebuttal to the black swan is. The horizon has been refracted. So where do they get the tangent? I'm going to run through some of the comments I left on this particular video, which was indeed published by Cleary. So we got at 45:41, which is the timestamp that I started this particular clip at. On Rumpus's screen, tangent to Earth's surface. It's the only line that was on every diagram. Next time, just ask, where did you get that straight line? That'd be a tangent line. The black line, as he referred to it. Shh, we debunked it with the black swan. They don't have a tangent line, that's a straight line, anymore. They have bent ones and require a tangent straight line. Earth is flat, like the line they need but can't get from a globe. Next time, just ask, where do you get the tangent? That would be the black line, the one on screen. The black line is a tangent. We debunked it. We only have one horizon. The horizon in your globe model was geometric before it was debunked by the black swan. They no longer have a physical geometric sphere edge, that'd be a tangent, for a horizon, as required by their geometric globe Earth model. Where do they get the black line? The tangent, that'd be straight. Answer, they don't. Say my name, Rumpus. And then there's a link to my video, which is called Tin Tangent. So I'll put that on as well after I've read out this last comment, which is, the Earth is incredibly flat, like that black line. That'd be a tangent. Required by the globe model and debunked by the black swan. Enjoy the aftertaste. So now I'll take you to a bit of my video.
Spheres at a tangent.
And have we got Earth as one sphere and another equivalent sphere in this example touching it?
You just need to man up, Nathan. Stop.
Sorry, you can suck my balls. As I tell you that your tangent needs to be straight.
Take this on the chin.
Take what on the chin? My straight line tangent being bent?
Take it on the chin.
On the tin chin?
Then take it on the chin.
On the tin chin? What? Your horizon is a tangent point in your geometry, and it needs a straight line to it for you to do geometry. The black swan is being defended by an assertion that the line is bent. So you can't do this geometry, you haven't got a tangent line.
I can see you could want to prevent me making my point. You don't want to let me finish my sentence, but I'm going to carry on as much as I can till you mute me.
And take it on the tin chin.
He didn't mute me.
You can take it on the tin chin as I teabag you. Take my balls on your tin chin as I tell you again. Your horizon is geometric in your model. It requires a straight line drawing to it. That's called a tangent, and you haven't got one anymore.
So you've got to stop me making the point because you're scared of it.
Take it on the tin chin. You tell us how the geometric horizon only exists in the maths. Why? Because you haven't got a straight line to it in reality. So you haven't got a tangent line. Maybe you'd like to use your little example where you've got two circles meeting at a tangent point. So curves can meet tangent points, right?
Listen to what I'm saying because you're scared of it.
Oh, right, I'm scared to tell you that your example with two circles butted up to each other to make your point that curves can meet tangents isn't an equivalent when you've only got one circle in your geometric model that requires a straight line to a physical horizon that we've debunked. You can take those nuts on your tin chin, mate.
You're worried that it will invalidate your whole argument because you won't let me make it.
You've already made it. Two circles butted up to each other means you've got one of those circles being a curve meeting a tangent point. Total false equivalence. Nothing to do with my argument that you need a straight line. So take it on the tin chin, my friend.
So, in summary, next time, just ask Rumpus, where'd you get the tangent? That'd be a straight line. If all lines to the horizon are bent. Well, the answer is they don't, they can't, but they require it to do geometry. A tangent's required. It's the straight line that'll be in every depiction that Rumpus ever shows you, and the chances are he'll challenge you to get one, so that you don't ask him where he got his. Definitely required for his globe Earth model, and definitely debunked by the Black Swan. I've been Nathan Oakley, and I'll see you all in the next video.